Okay, what I'm going to do is start with yesterday. The last thing we did was we talked about the horizontal asymptotes and vertical asymptotes, and what I want to do is go over a couple of examples on finding horizontal and vertical asymptotes because they are in your homework, and then you can ask me whatever homework questions you want to. So first of all, recall what is a vertical asymptote. We say that f of x has a vertical asymptote at some number a if either the limit as x goes to a from the right of f of x is infinity or negative infinity, or the limit as x going to a from the left of f of x is infinity, or it could be negative infinity. So vertical asymptote means if you have a vertical asymptote, it means near the vertical asymptote the graph of the function goes upward forever or downward forever. Okay. And what's a horizontal asymptote? We say that f of x has you know what, let me change a little bit here. Where is that? Let me change here a little bit and say the line x equals to a, okay? And f of x has a horizontal asymptote y equals to b, so that's the horizontal line, if either the limit as x going to infinity of f of x is b, or the limit x going to negative infinity of f of x is b. So it means that as x gets bigger and bigger, the graph of the function is getting closer and closer to the horizontal line, or as x gets smaller and smaller in the negative direction, then the graph is getting closer and closer to the horizontal line as well. So here are a couple of examples that I wanted to do. First of all, let's look at vertical asymptotes. Let's say I have the function f of x, which is given by 3 divided by x plus 1. Notice that this function, if I look at this function, what's the limit of this function at negative 1? Notice that the reason I picked negative 1 is because when x is negative 1, the denominator becomes 0. And we know that when the denominator goes to 0 and the numerator is a fixed non-zero number, then the ratio goes to plus or minus infinity. Okay? So in this case, I have a vertical asymptote at negative, when x is negative 1. So notice that I have a vertical asymptote at x equals to negative 1. And the reason it being that if I look at the limit as x going to negative 1 from the right side, 3 over x plus 1 has limit, well, what is that limit? What was that? Is it infinity or negative infinity? You see, here is, let's say, negative 1, and x is going to negative 1 from the right side. So that means that x is bigger than negative 1, right? So that means x plus 1 is bigger than 0. So the ratio is positive. When x is close to 1 on the right side of 1, the ratio is positive, but the denominator is becoming 0, so the ratio will go to infinity. Okay? And you can also see that when x goes to negative 1 from the left side, then it'll be negative infinity. But we don't care to look at that, because as long as one of the one-sided limits at negative 1 is infinity or negative infinity, we are done. There is a vertical asymptote there. So I have a vertical asymptote at negative 1. Everybody's okay with that? I don't have to check the left-hand limit at negative 1. Okay? Yeah.
Yeah, that was one of my biggest questions on the homework.
Yeah.
Was how do you tell if it's going to negative infinity or positive?
Right. Yeah, so in this case, you can say it's positive infinity. So keep this in mind. You have a ratio, okay? The numerator has a non-zero limit. The denominator has limit 0. Then the ratio will have limit plus or minus infinity. Is it plus or minus? To decide that, you have to think about what is the sign of the ratio when x is close to the limiting point, negative 1, on the right side of the left side. So when x is, in this case, when x is close to negative 1 on the right side of 1, so on the right side of negative 1, then x is bigger than negative 1, so x plus 1 is positive. And then you know that the ratio remains, even though the denominator goes to 0, the denominator goes to 0 as a positive number.
So could you like plug in if you're trying to figure out if it's positive or negative, and so you could plug in like a number bigger? Like
The problem with plugging in number is sometimes, let's say the graph is, let's say the quantity x plus 1, right? Here is negative 1, right? And yeah, so you better make sure that you pick x on the right side of negative 1 when you plug in numbers. But in some cases, though, when you do that, you have to be a little bit careful sometimes, because when you plug in number, maybe for that number, this denominator is negative, but you have to pick a little bit closer to negative 1. So how close do you have to pick to negative 1 before you get positive? In this case, it's simple enough that you could do that. Plug in any number on the right side of negative 1. But there might be other cases where it might not work. Okay, so let's do another example. So basically, you look for numbers where the denominator vanishes, okay? However, just because the denominator vanishes at a point doesn't mean you have a vertical asymptote there, okay? So for example, let's think about the function x squared minus 1 divided by x minus 1, right? This function, the denominator vanishes at 1, right? However, that is if the limit of the denominator is 0, but the limit of the ratio is not infinity, right? The reason is whenever you have a rational function, before you decide whether you have a vertical asymptote or not, try to factor out as much as you can and cancel out as much as you can. So in this case, you know that this is x minus 1, x plus 1 over x minus 1. and this becomes simply x plus 1, right? And so for this function, there is no vertical asymptote at 1. It doesn't have any vertical asymptote, right? Remember the graph of the graph of the ratio is the graph of the straight line with a hole at 1. Is that making sense? So my point is, just because the denominator vanishes at a number doesn't mean you have a vertical asymptote there. Before you decide that, you have to cancel out as many factors as you can, and then you can say that yes, if the denominator vanishes at a point, then I have the vertical asymptote there. So let's do another example. So in this case, no vertical asymptotes. No vertical asymptotes. Let's look at another example. Let's say I have the fraction x squared plus x minus 2, and let's pick something else here. X squared minus 2x plus 1. Let's say I have that ratio. Okay. I need to figure out where the vertical asymptote is, right? Now sometimes students make the following mistake. They will say, all I have to do is figure out where the denominator vanishes. So they will factor out the denominator, x squared plus x minus 2, and they will try to figure out where the denominator is 0. So they will say, well, this is x minus 1 times x plus 2 equals to 0. So x is 1, x is negative 2. So at x equals to 1, at x equals to negative 2, you have vertical asymptotes. And they will write their final answer as that. Okay. However, what's wrong with that is that notice that the numerator also has a factor of x minus 1. So until you cancel that out, you cannot say that. So you have to factor out the numerator as x minus 1 times x minus 1. And here you get x minus 1 times x plus 2. And then you cancel out one of these factors. Now you have x minus 1 over x plus 2. Now you could say, now notice that now the limit of the numerator is non-zero as x goes to negative 2, right? And the limit of the denominator is 0 when x goes to negative 2. So now you could say that the vertical asymptote at x equals to negative 2. Yeah.
So is it safe to say that if you have anything that cancels out in your denominator, there's a hole at that point and not a vertical asymptote?
Right.
Okay.
So, well, I have to be careful when I say that. It depends on what the function is, in fact. I'm going to give you another example to sort of give you a counterexample. The main thing you want to notice is that the possible vertical asymptotes are at the points where the denominator vanishes. Those are the possible points. However, you have to check whether the numerator also vanishes at the same points. Okay, if the numerator also vanishes at the same point, then you have to cancel out first. Okay. Let me give you another example. Just because I cancel out doesn't mean there is a hole. Okay. The reason is, let's think about the following example, right? Let's say I have x minus 1 divided by x squared minus 2x plus 1. Okay. Notice in this case, I can say, let's say multiplied with x plus 2 here. Okay. Notice in this case, I can write this as the following: x minus 1 times x minus 1 times x plus 2. So now if I cancel out, I still have x minus 1 in the denominator, right? So I'm going to have a vertical asymptote at 1. Is that making sense? Okay, so in this case, vertical asymptotes at x equals to 1, x equals to negative 2. Again, that's because when x is close to 1, the value of the function is going to infinity or negative infinity. Okay, the limit is negative infinity or positive infinity. Now let's think about horizontal asymptotes. Let's say I have the function f of x, which is x divided by x plus 1. And I want to know what's the horizontal asymptote of this function. Well, horizontal asymptote, in order to find the horizontal asymptotes, you have to compute two limits, okay? You have to find out what's the limit as x going to infinity of x divided by x plus 1. You also have to figure out what's the limit as x going to negative infinity of x over x plus 1. What's the first limit? What's the limit x over x plus 1 as x goes to infinity? What's that? Negative 1? It's 1, right? Because okay, you have a rational function. What was the trick? You factor out the highest power of x from the denominator and the numerator, and then you can figure out what's the limit. There is another thing you can, so whenever you have a rational function, you're finding out the limit as x goes to infinity or negative infinity. Keep in mind that only the highest order terms matter. So when x is big, right, x plus 1, that 1 doesn't matter. Those of you who are in computer science, you talk about orders, right? Order of a program. So if you have x squared plus x, the order is x squared, right? Right. So in this case, when x is big, that plus 1 doesn't matter. So you basically have x over x, and the limit is 1. Okay. Same thing happens here. When x is big and negative, that 1 doesn't matter, and you have the limit is 1. So what I get is that y equals to 1 in both cases. So that's my y equals to 1 is the horizontal asymptote. Now graphically, what happens here is that so graphically what happens, let me show you that. When I ask you this question to find the horizontal asymptotes, you don't have to give me the graph. I'm just trying to show you what it means to have a horizontal asymptote. So let's say I have that this is height 1, okay? This is height 1, and I have a horizontal asymptote at height 1, right? The graph of this function x over x plus 1, I also have a vertical asymptote, right, at what? Negative 1, right? So let me make that. So this is the vertical asymptote at negative 1. The height here is 1. The graph of x over x plus 1 looks like this. When is it 0? When x is 0, it's 0. So it goes through the point 0, 0. And it looks like this. Okay, it's getting closer and closer to this horizontal line. So the gap between, so as x gets bigger and bigger, the gap between the horizontal asymptote and the graph is decreasing to 0. The gap between the graph of the function and the horizontal asymptote is decreasing to 0 as x gets bigger and bigger. And what is happening on the other side? Well, on the other side, what's happening is this. Okay? So that's how the graph of x over x plus 1 looks like. Is that making sense? Was that?
It goes, on the other side, it goes to positive.
On the other side?
Left-hand side, it goes to positive.
Oh, yes, yes. I have a wrong graph here. Thank you. The when you have x on the when x is negative, notice that when x is negative, less than -1, x over x plus 1 is in fact a positive number, right? Because both the numerator and the denominator, they are both negative. So you're right. So I should be I should be drawing this. Yes, I didn't remember that correctly. Okay, that's how it's gonna look like. Is everybody okay? Reflected? No. What are you reflecting? You're talking about reflecting this? I'm talking about x over x plus 1 being positive when x is negative. When x is less than -1. See, I do a wrong graph because I drew it on the other side. Okay. All right. So, okay. So that's what it means to have a horizontal asymptote. How about this function? Let's say I have the function x plus 1 divided by x. What is the horizontal asymptote in that case? Well, in this case as well, what's the horizontal asymptote? Yeah, because the limit at infinity or negative infinity is still 1 here. So I get the same 1 from both limits. So there is only one horizontal asymptote. And in this case, I think the graph of this function looks like the following. Let me use red for that. So the graph looks like this. And now I think I mixed up the, if you have a calculator, please check that this is the case. So I mixed up the two graphs before. So that's how the graph of this guy. So now you see again the gap between the graph and the horizontal asymptote is decreasing, okay, to 0. Everybody's okay? Okay, I'm going to give you one more example because sometimes students think that, hey, if you have a horizontal asymptote, the graph does not cross that, right? Well, here's an example where it's going to cross the graph. Let's think about the function sine x divided by x. In this case, what's the limit as x going to infinity of sine x over x? And what's the limit as x going to negative infinity of sine x over x? Well, whatever sine x is, I cannot predict sine x as x goes to infinity because it's doing this, right, between -1 and 1. The values of sine x is vibrating between -1 and 1 as x goes to infinity. But the denominator is getting bigger and bigger, right? So you have a bounded number between -1 and 1, and then you are dividing by bigger and bigger numbers. So the ratio should go to what? 0. So ratio should go to 0. And so the limit in both cases 0, so you get only one horizontal asymptotes, right? And in this case, the graph looks like the following. Okay, let's say here's 1, okay? Oops. Let's say here's 1. and the graph looks like basically okay, I'm not being precise, of course. I'm just trying to make the point that what is happening is that in both directions the graph is going above and below the x-axis, okay? But the gap between the graph and the x-axis is going to 0. Am I making sense? So that's what's happening. In my graph on the left is pretty bad. Say it again. Well, yeah, it's vibrating, but it's not quite the same. Sine is always between -1 and 1, right? Yeah, sine starts from 0 and it goes from -1 to +1, right? This is sine x over x. See, sine x, the height is like this, coming down to -1 and then goes back to +1, coming down to -1, goes back to +1, right? This is here, the height is decreasing to 0. Okay? The sine graph, the gap between the graph of the function and the x-axis doesn't go to 0. Sine graph does not have a horizontal asymptote, right? So this is not the sine graph or the cosine graph. I mean, they have a similarity, which is both of them are vibrating, okay, but it's not the same. So here, what's happening is like this, okay. I guess I made my point. My graph is not nice, but my point is the graph is always going above and below the x-axis. However, the gap between the graph and the x-axis is slowly becoming 0. Okay. Everybody's okay? So that can happen if you have a horizontal asymptote for some functions. Okay. All right. All right, that's all I wanted to say, and then I want to do the homework problems. Yeah. I went over the vertical asymptote problems at the beginning. Yeah. Yeah.
Express the function in the form of circle G.
Section 1.3. Which problem did you say number? 41. Okay, express the function in the form f circle g, right? So now I'm basically going to answer your homework questions. Let's see how long you can keep me busy with this. And since someone asked me a question from 1.3, I'm going to try to take as many questions from this same section, okay? So first of all, we're going to start with section 1.3. And the problem that was asked was number 41. And 41, we are given a capital F of x function, which is 2x plus x squared, 2x plus x squared, to the exponent 4. Okay, to the exponent 4. And what we have to do is we have to express this function as the composition of two simpler functions, okay? So we want to write f of x as the composition f circle g of x, which means it is f of g of x. So our goal is to find lowercase f and lowercase g so that f of g of x is the same as capital F of x. Is that making sense? Is the question clear to you guys? Is the question clear? Okay, so what you want to do is, in this case, is imagine, see what you're doing is you're first of all, in order to compute this function, you're going to compute whatever you have inside the parentheses, right? And then you're going to raise it to power 4, right? So raising to power 4, call that your so that's the second thing you're doing. Call that your outside function, and your inside function will be whatever you're computing first, okay? So in this case, you take the outside to be raising to 4, actually 4, and then you take inside g of x to be 2x plus x squared. And then you can check whether it works. Let's check if it works. What is f of g of x? Well, it is f of 2x plus x squared, which is now 2x plus x squared to the 4, right? Which is exactly capital F of x. If you want to check, you can check. Okay? So again, you are trying to express the capital F of x function as the composition of two simpler functions. And that's how you can pick. Let me maybe do two more like this. 42 you said? Yeah, but I didn't assign 42, I think. Oh yes, I did. Yes, sorry. Yes, 42 you have cosine squared x, right? Instead of cosine doing that, let me make it a little bit more complicated. Let's say I have the function capital F of x is the root of 1 plus cosine x. Okay? I want to express this as the composition of two simpler functions. So how are you computing this function? Well, you're going to compute whatever you have inside the root first, right? So I'm going to call that my inside. G of x would be 1 plus cosine x. And then I'm going to pick my outside function is what I'm doing next. Well, I'm taking the square root, right? So that square root function, root of x, would be my outside function. So then notice that f of g of x is the same as f of 1 plus cosine x is the same as root of 1 plus cosine x, right? Because how do you calculate f of that? You replace x by that, right? Is that making sense? Okay, let's do another one. Yeah, I'm going to get to 47 in a bit. Let me do one more example. Like this. Suppose I have the function x plus 1 divided by x plus 2, and then I have the root function. In this case, if you want to express this as a composition of f and g, what would you pick for the inside function? You would pick for the inside function the fraction x plus 1 over x plus 2, right? And what would you pick for outside? Root of x, yes, very good. Okay, now let's look at 47. 47, you have the function, what is that, r of x? So you have the function r of x, and r of x is the square root of root of x minus 1. Okay, so now your goal is the following. You want to express this as f circle g circle h, right? Evaluated at x. You want to write it as the composition of three functions, and 3 simpler functions. What's the meaning of f circle g circle h of x? It means f of g of h of x. Let's see, I have enough parentheses. Yeah. Okay. So what can I pick for the innermost function, then the middle function, and then the outmost function, right? Well, in this case, how are we computing this function? Okay. What was that? Yeah. Well, first of all, the first thing that you try to compute here, right, is root x, right? So I'm going to call that h of x. I'm going to call that h of x. H of x will be root of x. And then you're computing root of x minus 1, right? I'm going to call that g of x would be x minus 1. So basically whatever h is, you're subtracting 1. So my g of x would be x minus 1. And then my f of x, my outmost function, I can take that as root of x as well. Let's see if that works, okay? Let's check. What is f of g of h of x? Well, first of all, this is f of g. What is h of x? Root x. And then what is g of that? G of root x would be root x minus 1. Well, then what is f of that? Well, f means you take the root of whatever you have. So root of root x minus 1, right? That's the function that I had. Is everybody okay with that? All right. Yes. Now problem number 50. Okay, in problem number 50, you have the table, and then you need to calculate those values. Okay, so problem number 50. X could be 1, 2, 3, 5, 6. Okay, x could be 1, 2, 3, 4, 5, 6. And then the second row is for f of x. F of x is what? 3, 1, 4, 2, 2, 5. 3, 1, 4, 2, 2, 5. And what's g of x? 6, 3, 2, 1, 2, 3. 6, 3, 2, 1, 2, 3. Am I right? Okay. You have to find a couple of values. For example, you have to find a number D. Part D is find g of 1, right? So what is g of 1? Well, how do you find g of 1 first, right? G of 1 means what? G of, well, what is g of 1? Well, you go to the third row. What is g of 1? 6. Well, then you need to compute g of 6, right? So what is g of 6? 3. Right? Say it again. First of all, you plug in g of 1. G of 1 is 6. And then you need to find g of 6. G of 6 is 3. Okay? Let's do one more, maybe E. G circle f of 3. G circle f of 3. You evaluate f at 3 first, right? So this is g of f of 3. You evaluate f at 3 first. What is f3? f of 3 is 4. And then what is g of 4? F of 3 is 4 right here, and then g of 4 is 1, right? Is everybody okay with that? The second two, let me put them in red. That's pretty easy, right? Okay. All right, so anything else from 1.3? 17? Okay. 17 says what? Okay, so 17, you have half of 1 minus cosine x, right? Y is half of 1 minus cosine x. What you're asked to plot the graph of this function, okay? By using graph transformation. So you're asked to start with the graph of cosine, and then you apply the transformations, okay? So what's the graph of cosine? Now, I am only going to concentrate from 0 to 2 pi, because once you know the graph for 0 to 2 pi, you know what happens everywhere else, okay? So all right, so let's say the height here, let's pick the height here to be 1 here, and then pick 1, 2, 3. You know what, I'm not going to be that precise. Let me just say that I am going to pick, let me, okay, let me just say that I am going to pick 1 here, but pi over 2, I'm going to pick it here. And then pi would be here. And this would be 3 pi over 2. And this would be 2 pi. You guys are okay with that? So I'm just picking my scale for pi over 2, and then pi, 3 pi, and 2 pi. What's the graph of cosine between 0 to 2 pi? Well, at 0 the value is 1, right? So, and then it goes down like this. At pi the value is negative, so it comes down to this. And then from pi to 3 pi over 2 it looks like this. And then at pi it comes up to 1, right? So that's the graph of cosine between 0 and 2 pi, okay? And then I have to find the graph of what? 1 minus cosine x, right? So what transformation should I apply first? What transformation should I apply first? Well, multiply by negative. That's the second thing you're going to do, right? So what is the graph of negative cosine x? No, so this is the graph of so the blue one is the graph of cosine x. Now I'm asking the green one, what's the graph of negative cosine x? What transformation? Reflected across x-axis. Reflect across x-axis, right? So the graph, so that means the point here will come here, right? This point will stay here, that point will come up here, this point will stay where it is, and this point will come down here, right? So the graph looks like so it's a reflection of the blue curve, right? Well, now I need to add one, right? So when I add one, what happens? So let me use black. when I add 1 to it, what happens? What transformation when I add 1? I'm adding positive 1. You go up by 1 unit. You're not replacing x by x plus 1. It's important to understand that there is a difference between saying that adding, with f of x, if I have 1 plus f of x, go up by 1 unit. But if I have f of x plus 1, then you go to the left by 1 unit, right? Okay, so keep that in mind. So what's the graph of 1 minus that? Well, I take my green curve by 1 unit upward, right? So this point will come up here, this point will come up here, and this point will come up here, this point will come up here, this point will come up here, right? So this will be like this. Okay, so that's how the black one looks like. Okay, you're shifting the green one unit upward, right? Okay, so lastly, you're multiplying by what? Let me use red. Multiplying by half. 1 minus cosine x. So multiplying by half means vertically you shrink it by a factor of half, right? The heights are, whatever the heights are, they will all become half of the. So think about the height of the black curve, right? Heights of the black curve, it will shrink by a factor of half, right? So what's going to happen? This point will remain because this here the value is 0, right? This point will remain right here, right? Because the value of 1 minus cosine x is 0 there, so half of that is still 0. Where will this guy go? It'll go, so right now the value there is what? 2? So it's going to come up, so this point will be, so let me, so I'm going to get a point right here. This point here will go here. Where will this point go? It will go halfway down. Okay? This point will go halfway down right here. So now the graph looks like this. And this, okay? So whatever the black curve is, everything is going down by a factor of 2. All the heights are going down by a factor of 2. Is that making sense? Okay, so the final answer is the red one, okay? The final answer is the red one. Yeah? Well, that's different. What I said in the class, the problem you did was it was not this one, okay? The problem you did was, okay, so you're multiplying by half, so there is a difference between, so let me make a remark here. There is a difference between writing half of f of x and then writing f of half of x. So when you have half of f of x, it means that you shrink the vertical heights by a factor of half, okay? But when you have f of half of x, then it's a stretch along the x-axis. So there is a difference, okay? So half of f of x is a vertical shrink. F of half of x is a stretch along the x-axis, okay? How about if I have a 2f of x here, and then I have f of 2x. The 2f of x is a vertical stretch. F of 2x is a horizontal shrink. I think that was a problem in what section? Do you remember? What section was that in? Was it in the same section? Yeah, I think that was problem number 5. So you'll see that there is a difference between f of half of x and the writing the half outside of the parentheses. Okay? Any other questions in section 1.3? Anything else? 51. Okay, I am not going to draw the graphs on the tablet, okay? So let me just read it for you. So let's think about problem number D, right? In problem number D, you have what? G circle f of 6, right? G circle f of 6. This is what you have. So this is G of f of 6, right? So you have to figure out what is f of 6 from the graph. So what's the graph of f? The graph of f is the red one, right? So look at the red one and figure out what is f of 6. Well, f of 6 would be 1, 2, 3, 4, 5. So f of 6 is 6, right? If you look at, you don't have the graph, you can look at somebody else's. From the graph, what is the height of the graph of f at 6? What is the height of the graph of f at 6? You guys realize that that's 6? It is 6, so this is g of 6. Now you look at what's the height of the graph of g at 6. What's the graph of g at 6? Hey. Yeah, so you're going to say that it is undefined because the graph of g only goes up to 4. So that's you have to take that to be the domain of the function. So this is undefined. Undefined. Does that make sense? Because 6 is not in the domain of g. 6 is not in the domain of g. Because the graph only goes up to 4. Okay, the point is you first of all find out the height of the graph of the inside function at whatever is given, and then whatever that is, you evaluate the other one. Let's do one more here. What is g circle g of negative 2? G circle g of negative 2. This is g of negative 2. What's the height at negative 2 for g? What's the height of the graph of g at negative 2? 1. So you get g of 1, and then what is the height of g at 1? 1, 2, 3, 4. It is 4. So you get 4. Everybody is okay with that? Are we doing okay with that? How did I find? Oh, on the graph? Each cube has height and length 1, right? In the graph. So what is g of negative 2? Well, you go to negative 2, right? From the blue graph is the graph of g, right? So when the x coordinate is negative 2, what's the height of the curve, blue curve? Horizontal. So from 0, go 2 units to the left, right? And then what's the height of the blue curve there? 1. So you get g of 1. And now what is g of 1? Well, what's the height of the blue curve at 1? Go 1 unit to the right. And then what's the height of the blue curve at 1? 1, 2, 3, 4, right? Does that make sense? Okay. Or anything else from section 1.3? I think we can move on to another section maybe. Okay, what should be the next one? 1.5? Okay. I am not going to do the problem in 1.4. If you want me to help you out with that, just come to my office, okay? What was that? Or go back, okay, 1.1, that's fine. 1.1. Okay, which one? Section 1.1. And you said which problem? 3 and 27. Okay, again, this is a graph problem. There is a graph given, and I'm not going to try to draw that on my tablet. So it says the graph of a function is given. State the value of f of 1. Well, the value of f of 1 is the height of the graph at 1. So what is that? 3. And then it says estimate the value of f of negative 1. Okay, what is f of negative 1? Well, it is about, I would say, 1/3. Negative 1/3, in fact, negative 1/3. Okay, so that's just estimating. For what values of x is f of x equal to 1? F of x is 1 when x is what?
0
and 3, yeah. Is that making sense? You don't have the picture?
No, I do have a problem. I don't know how to read the graph.
Okay,
So what comes wrong?
yeah, so that would be better if you, I can show you by hand, okay? Any other, so then the next question was 27, right? 27, okay. Uh, 27, you are given a function f of x, and this is 4 plus 3x minus x squared, and you are asked to compute the following ratio: f of 3 plus h minus f of 3 divided by h. So that's what you need to compute, okay? Is everybody clear? F is given and they are asking you to compute this, where h represents a real number, okay? So what is that equal to? What is f of 3 plus h? F of 3 plus h, in order to find that, you are going to replace x by what? You're going to replace x by 3 plus h. So this is, I'm going to have 3 plus h squared here. So this whole thing is only f of 3 plus h, right? Minus, what is f of 3? You're going to replace x by 3 now, right? So 4 plus 3 times 3 plus, minus 3. Minus 3 squared, and then divided by h, right? You guys agree with that? F of 3 plus h minus f of 3. Some of the usual mistakes made in the exam are like this. People usually, when they plug in 3 plus h, sometimes they only plug in h. Sometimes they plug in 3 plus h in one place, and they forget to replace x by 3 plus h at other places. So keep that in mind. And after this is just a simplification problem. You have to multiply out everything here, so you get 3 times 3, that's 9, plus 3h, minus, what is 3 plus h squared? If I take 3 plus h squared, what is that? 9 plus 6h plus h squared, right? Minus, what do I have in the second brackets? I have 4 plus 9 minus 9, right? So that's just 4. Notice that 4 cancels out. Well, let me write down 4 plus 9 again, plus 3h, minus 9, minus 6h, minus h squared, minus 4, divided by h. Now 4 cancels out, 9 and 9 cancels out. Is that it? H and 3h and negative 6h is what? Negative 3h. And then I have negative h squared, and then divided by h. And then this is h can be factored out. I get -3 negative h divided by h, and then you can cancel out h and h, and finally you get what? And this is it. Well, we are not going to take the limit yet. Yes, we're going to do that in section 2.1. Yeah. Is everybody doing okay with that? All right. Anything else from section 1.1? 37. Uh, 37 is I want you to pay attention to what it says. If you need a copy of the solutions, I can print out a copy for you and send it to you by email. Okay. So don't rush yourself to write down everything. Then you can't pay attention to what I'm doing. You said 37, right? And 37 is what? It says find the domain of the function. You are given a function f of p, and that's the root of 2 minus root of p, right? Now instead of x, they are using p, so that's not a big deal. Now, in order to understand how to find the domain here, first of all, look at the outmost root function, root. You cannot have negative inside of that, right? So you want, first of all, you want 2 minus root p, right? You want that to be non-negative. Is that clear? Also, I have another root inside, right? So that tells me p has to be what? P has to be positive. So we want to find, so we want to know for what values of p will that make sense. So from the first one, right here, what do I get? I get 2 is larger than root p, right? So then root of p is less than or equal to 2. And then if you square, you get p less than or equal to 4, right? Okay. Again, we already know that we want p to be positive. We already know we want p to be non-negative. Now we are saying p has to be less than 4 as well. So what's the domain? Let's say here is 0 and here is 4, and the domain is everything here. Okay. So the domain of f is from 0 up to 4. Did that make sense? So first of all, you need p to be non-negative because of the root p, and then you also need 2 minus root p to be non-negative because you have a root on that. So then you see that p has to be less than 4. Because if p is greater than 4, right? Like for example, let's say p is 5, then root of p would be bigger than 2. Then 2 minus that would be negative. Okay. All right. Everybody is okay with that? Yeah. 29 says what? F of x is 1 over x. F of x is 1 over x. And you have to find f of x minus f of a over x minus a. So find f of x minus f of a over x minus a. Okay, I'm not going to give you any breaks today, just because it's answering questions. If you need to go to use the restroom, go ahead and use the restroom, okay? Otherwise, I'll just keep answering questions. Okay, so this is what we have to calculate. So what is that? What is f of x? F of x is 1 over x. What is f of a? F of a, 1 over a. And then denominator I have x minus a, right? I have to simplify this. How would I simplify this? There are a couple of ways of thinking about this, but one way, you have a fraction in the numerator, right? What's the common denominator? X times a. And then what are you going to get in the numerator? You're going to get a minus x, right? And divided by x minus a. And this is equal to, notice that in the denominator what I have is x minus a over 1, right? So this is what I have. So I can write this as a minus x divided by xa multiplied with 1 over x minus a. How do I cancel out x minus a? Notice that a minus x is the same as negative x minus a, right? So now I can cancel them out, and I am left with what? Okay, so I get negative 1 over xa. I'm going to redo this problem a little bit differently, just in case you didn't like this. So redo in a different way. So redo from the second step, okay? So instead of doing this step here, what I'm going to do is, you said that the common denominator is xa, right? So what I'm going to do is, I am going to write this as this, and I'm going to multiply and divide by the common denominator, okay? Multiply and divide by the common denominator, the whole fraction. So what do I get then? Well, when you multiply 1 over x and xa, what do you get? You get a. When you multiply 1 over a and xa, what do you get? You get x. Okay. In the denominator, I am just going to write xa multiplied with x minus a. I'm not going to multiply out. Okay? And then notice that in the numerator I have negative x minus a, and then divided by xa, x minus a, and I am getting the same thing, right? Because they cancel out. How did I get the negative? Okay, so notice that I have a minus x here, right? So I am factoring out a negative 1. So then I get x negative of x minus a. Is that making sense? Okay. Either way is fine. Whichever style you like better, you can use that. Okay, so anything else from 1-1? Any other questions from 1-1? No? All right, move on to another section. Anyone else? Yeah. 51 in 1-1? All right. 51. 51 is find an expression for the function whose graph is the given curve and the line segment joining the points the line segment joining the points 1, -3 and 5, 7. Okay, so let's say this point is 1, -3, and I have another point that's 5, 7. I'm not being precise here. All I'm saying is these are the 2 points, and there is a line segment joining the 2 points, and we want to find a function whose graph is this. Okay, well, this is just a straight line, right? And how do I find the equation of this straight line? What's the slope? Yeah, it's rise over run. So it's 7 minus -3 divided by 5 minus 1. So what is that? 7 plus 3, that's 10. 4, which is 5/2, right? So then what's the equation of the line? You can use either one of the 2 points, right? Y minus, which point are you using? Y minus, which point are you going to use? 5, 7 or 1 minus 3? Okay, y minus 7, 5/2, x minus 5. Okay, so now you can simplify this by multiply both sides. Well, not multiply both sides. You're going to solve for y, okay? Sorry. You're going to solve for y. What do you get? 7 plus 5/2 times x minus 5. And you can keep it this way, but you can simplify a little bit by saying this is 7 plus 5/2 x minus 5 times 5, 25 over 2. And then this is 7 minus 25 over 2 plus 5/2 x. And what is that? That's 14 minus 25, right? What is 14 minus 25? Minus 11 over 2 plus 5/2 times x. So this is my function. This is the formula for the function y. The graph of this function will represent that straight line. You need to restrict the domain though between the given values of x. Okay, so what are the given values of x? -3 to 5, right? -3 to 5. The reason is this between -3 and 5. When x is between -3 and 5, you only get the line segment. But if you take x to be anything, then you get the entire line. That's the difference. Is that making sense? By the way, you could have left your answer right here. I don't mind. Okay. Which one is looking nicer? Well, I think they are both about the same. Okay. Okay, so the only point important here is that if you want to get only the line segment, not the entire line, then x has to be between -3 and 5. It is between 1 and 5. I took -3 to be the x-coordinate for the first point. Sorry. Thank you for noting that. This is 1 to 5. Is that why you were confused? Okay. There are 2 points, 1 and -3 and 5 and 7. So x has to be between the x-coordinates. That's what I said. But when I wrote, I wrote -3 because I was reading incorrectly. Okay, x has to be between 1 and 5, between the x-coordinates of the points. All right, that's 51. What else is? What else from? This is 1, 1, right? What else from 1, 1? What else from 1, 1? Yeah. Was that? 49. 49, you have a piecewise function. And f of x is x plus 2 and x squared. And x, this here is when x is less than -1, here when x is larger than -1. Okay, so that's how the graph, that's how this is defined. What's the domain? When x is less than -1, the function is given by the formula x plus 2. Can you compute x plus 2 for any x less than -1? Okay, so all of those are in the domain. When x is larger than -1, can you compute x squared for any of those? Yes. So the domain is everything. Right? Okay, and the next thing is to sketch the graph. The question is, what's the domain, right? The formula for the function is given by this when x is less than -1, right? So can you compute this? Does this formula make sense for any x less than -1? Yeah. I mean, if x is any real, in fact, this formula makes sense for any real number x, right? Because you can always add 2 to any real number. So this makes sense for any x less than -1. This guy makes sense for any x larger than -1, right? So the domain would be everything because this function is defined for any real number x. You have to sketch the graph of this as well, so let's try to do that. And I'm not going to be precise on it, I'm just going to show. At -1, let's say -1 is here. At -1, what's the value of the parabola? The value of the parabola is 1, right? But I have a hole because it's not given by the value of the function is not given by the parabola at -1. This is -1. Then the graph of the parabola looks like this, right? To the right side of -1. On the left side of -1, the graph of the function is given by x plus 2. What's the graph of x plus 2? The graph of x plus 2, when x is -1, you get 1. When x is -1, the value of the function is what? 1. So in fact, I'm going to do this now. And then what's the let's pick another point. Let's say x is -2, then you get this point here, right? On the line. So then you have the straight line. So that's how the graph looks like. Again, the way to graph a piecewise function is that you draw both curves. You draw the parabola, you draw the line, and then for the parabola you delete anything to the left of -1, and for the line you delete anything to the right of -1, because the function is given by the line left of -1, it's given by the parabola to the right of -1. Okay? Is that making sense? So, I mean, let's say you drew the entire parabola, right? So you drew the entire parabola like this, and then you drew the entire line like this, right? Then you have to delete. You have to delete the portion of the line to the right of -1, and the portion of the graph parabola to the left of -1, and then you have your graph. Yeah.
So say you had an answer that the domain of all real numbers on the test, but that are you want to
Say it again. Oh, instead of writing this, you're writing this.
Yeah.
Yeah, that's fine. That's fine. Yeah, this symbol R it represents the set of all real numbers. So that's the same. It represents negative infinity to positive infinity. Okay. So if instead of writing negative infinity to positive infinity, if you want, you can write just that R as well. Okay. Anything else from 1.1? Or should we move on to another section? 1.5, everybody wants to go to 1.5, okay. So no one has questions on 1.2, I assume? 1.2? Okay. 1.5 is the next section we are going to. Section 1.5. You know what? When I said I'm not going to give you a break, I lied, because I need a break. Okay, so I'm going to take a break for just 2 minutes, and I'll be back. I have to go to the restroom. Okay. So I'll be back. Okay, 1.5. Somebody asked a question. 11. Okay, so I have to sketch a graph. Okay, it's given by the parabola when x is between -1 and 1, right? So let's say here is -1. It's given by the parabola, and at 1 it's not given by the parabola, but in between. So is the middle one is given by the parabola when x is between -1 and 1. It's given by the parabola at -1, but it's not given by the parabola at 1. When x is 1, though, it's given by the value 2 minus x, right? So when x is 1, 2 minus x is what? 2 minus x is 1, right? So you get the point. You do get the point here for that. And what's the graph of 2 minus x? So that's goes up by 2. Yeah, so the graph will be like this. Sorry. Since I have straight lines here, let me use them. So this is y. This part is the y is x minus 2, okay? Sorry, 2 minus x. This is part of 2 minus x. And what's the other one? What's the other one? 1 plus x when x is less than -1. When x is -1, 1 plus x is what? 0. So that means you are right here. And then to the left of -1 is given by 1 plus x, and the graph of 1 plus x is going to look like a straight line also, which would be like this. Something like this, okay? Is everybody okay with that? Well, okay, think about how would you draw the graph of the line y equals to 1 plus x, right? Y equals to 1 plus x. You need, in order to draw a line, you need 2 points, right? So 1 point I got by saying that when x is -1, I get 0, right? When x is negative 1, 1 plus x is 0. And you can plot another point. Let's say when x is negative 2, y is negative 1, right? So let's say this point here is negative 1, negative 2. So this is negative 2 here, and then you get negative 1. Right? And then you add the 2 points that you obtained in a straight line. Is that making sense? Yeah.
That's not a hole, right?
When x is negative 1, it's not given by the value 0, right? In the formula for the let me show you the formula for the function. Oh, I didn't write that down. Oops, sorry. The function is given like this, right? It's given by 1 plus x when x is strictly less than negative 1, right? So when x is negative 1, the value is not 0. The value is given by x squared when x is exactly negative 1, right? So when x is equal to negative 1 and less than 1, the value is given by x squared. Otherwise, the value is given by negative 2 minus x when x is larger or equal to 1, right?
Yeah, I got it.
Yeah. Anyone else? You guys see how to get this? If you are unsure, the thing that you want to do is you want to draw each of the curves separately, and then get rid of the parts which are not in the corresponding formula, right? So first of all, I want to draw this. Draw the graph of this function when x is less than negative 1. I know that the graph of this guy is a line. So in order to draw the graph of the line, I need 2 points. So because it's on the left side of negative 1, I pick one of the points to be negative 1. When x is negative 1, I get the point 0, right? But the 0 is not in the domain, that's why I keep a circle here. And then when x is negative 2, you get negative 1, so you get another point here, and then you add them in a straight line, right? Okay? And when x is between negative 1 and 1, this is given by the parabola, so I know that between negative 1 and 1, the parabola looks like this, right? Between negative 1 and 1. And then after 1, it's given by 2 minus x, so when x is 1, the value of this guy is 1. And then when x is 2, the value is 0 right here. And then you add them as a straight line. Is that making sense? $29. Oh, after drawing this, right, that's not the only question, right? It says, use it to determine the values of a for which the limit exists, right? The limit at a exists. So for what values of a does the limit exist? The question is, find values of a. Find values of a such that the limit as x going to a of f of x exists. Okay? Well, in this case, you better ask for what values of a the limit doesn't exist. Well, the only point where the limit doesn't exist is what? -1. Right? Everywhere else the limit exists, right? Is everybody okay? So the limit exists. So So to answer this, well, the limit exists everywhere except at -1, right? So this guy, the limit x going to a of f of x exists for all values of A except -1. And you can write this by saying that the final answer is everything up to -1 and -1 to infinity. So as long as A is inside of this domain, the limit exists. Yeah.
Other than for the next problem, I've got a question.
Okay. Go ahead.
For number 15,
Mm-hmm.
how do you know which part of the graph has the whole, or which part of the graph has the open circle and which part has
Okay.
the closed?
I'm gonna get to number 15 in a second. Okay. Anyone has any questions on this problem? If you have questions, please let me know. Did the graph make sense to you now, or should I go over that again? Okay. Oh, we are asking ourselves find the values of A for which this limit exists. Find the values of A for which the limit exists. We are saying the limit exists for any A except at -1. So the limit exists at any A except for negative. So I'm getting rid of -1. So open parenthesis means it's negative. -1 is not included. Is that making sense? Okay. All right, let's look at 15 then. 15 says, sketch the graph of an example of a function f that satisfies the following conditions. The limit as x going to 0 from the left of f of x is given by -1, and the limit as x going to 0 from the right of f of x is +2, and f of 0 is 1. F of 0 is given to be 1. So you just have to draw a graph which will satisfy these conditions, any graph. And there are many possibilities, okay? So you just have to give one possibility here. So let me draw my x-axis, my y-axis. Okay, what would be one possibility? Well, first of all, f of 0 is 1. So I'm going to get this point here. So this is height 1, and the f of 0 is 1, so I get that point. Now at 0 on the left side the limit is -1, right? So let's say here is -1. So here is -1, and on the right side the limit is +2. So I get a hole like this. Okay. So would this satisfy? Let's see if you agree with me. How about I draw this straight line here, and how about I draw this straight line here, and together with this point here, would that satisfy all the conditions? The limit at 0 from the right is 2. The limit at 0 from the left is -1. The value of the function at 0 is 1. Right. What's that? 1? Yeah, that's part of the graph. So everything that is green is part of the graph. So the value of the function at 0 is 1, and then the limit at 0 from the right is 2. Limit from the left at 0 is -1. So this is one example, but there are many other possibilities, right? Or how about I can say that it's given here by something like this. That's another possibility, right? Yeah, there are so many other possibilities. Instead of that, I can have this, right? Instead of that, I can have this, okay? So you can make whatever you want. The simplest one was just a straight line. No, you're just sketching an example of a graph. Yeah. Everybody's okay? All right. What's the next problem? 29. Uh, 29, that's the limit question. What you have is the limit as x going to -3 from the right, -3 from the right of x plus 2 divided by x plus 3. Okay? And so how do I find this limit? Well, what's going on here? Notice the following, right? What's happening to the numerator? What is happening to the numerator when x goes to -3 from the right? It goes to -1. What is happening to the denominator? It is going to 0, but is it going to 0 from the right or the left? Notice that if this is -3, x is going to -3 from the right. So that tells you that x is larger than -3. That tells you x plus 3 is positive, right? So x plus 3 is going to 0, but it is going to 0 from the right. That is, it is positive and going to 0, right? Am I making sense? So the denominator x plus 3 is positive when x is close to 3 on the right side of 3, right? Sorry, when x is close to -3 on the right side of -3. So then, because it goes to 0 from the right, then you have a negative quotient, right? Negative ratio, because the numerator is negative, the denominator is positive, the ratio is negative. But when that happens, the limit is what? What did I say about the limit when you have numerator goes to a non-zero number, denominator goes to 0? The limit is plus or minus infinity, but in this case it's what? It's negative infinity because the ratio is negative, right? Yeah.
In this section, I'm very confused by how to determine whether it's like constant infinity or indefinite.
That's what I'm saying.
Yeah.
In this case, first of all, you have to remember that what I said, if the numerator goes to, if the limit of the numerator is a non-zero, the limit of the numerator is a non-zero number, the limit of the denominator is 0, then the limit of the ratio is positive or negative infinity. Now, is it positive or negative? Well, that's going to depend on what's the sign of the ratio when x is close to -3 on the right side of -3. So first of all, you realize what I said. If the limit of the numerator is a non-zero number, limit of the denominator is 0, limit of the ratio would be plus or minus infinity. Which one is it? Plus or minus? Well, ask yourself, what's the sign of the ratio when x is close to -3 on the right side of -3? Yeah. So is it when x is close to -3 on the right side of -3, the denominator x plus 3 is positive, the numerator is close to -1, so it's negative, so the ratio is negative. So it should be negative infinity. Say it again. Another one? Yes. 33. Uh, 33, you have x going to -2 from the right. X going to -2 from the right. X minus 1. over x squared multiplied with x plus 2. Okay? Alright, so let's figure out what's going on. What's going on with the numerator? What's the limit of the numerator? Minus 3. What's the limit of the denominator? The limit of the denominator, notice that one of the factor is going to 4, right? The first factor in the denominator goes to 4, but the second factor goes to 0. So together it goes to 0. But now you have to decide, say it again. Did you say how?
So negative 2
When-
is negative 4.
When x is negative 2, this is 4, but this is 0. 4 times 0. Okay. It goes to 0, but what's the sign of the ratio? So I know that the limit of this guy is either plus infinity or minus infinity, right? Which one is it? Well, you have to decide what's the sign. So when x is, here's let's say negative 2. When x is close to negative 2, on the right side of negative 2, what's the sign of the numerator? Negative, because it's close to negative 3. What's the sign of x squared? Positive, because it's a square. What's the sign of x plus 2? It's positive, right? So to all together you have negative. So basically then the answer is negative infinity. Did that make sense? When x is close to negative 2, on the right side of negative 2, x plus 2 is positive, right? Why is that? Because x is greater than negative 2, so x plus 2 would be greater than 0, right? So think about when x is close to negative 2 on the right side of 2, x plus 2 is positive, x squared is positive because it's a square, and then in the numerator you have negative. So negative, positive, positive together is negative. Yeah. 31. You guys are done writing that down? Should I go back up? Okay, 31 you have the limit. X goes to 1. And 2 minus x over x minus 1 whole squared, right? Everybody's okay? Alright, let's see what's going on here. What's the limit of the numerator? When x is close to 1, 2 minus x is close to 2. Sorry, 1. 1. And then, what's going on with this guy? It goes to 0, but is it positive? Of course it's positive because of the square. I don't even care whether x goes to 1 from the left or the right, because of the square, it's all is non-negative, right? All is positive. So then, when x goes to 1 from either side, it doesn't matter. It goes to 0 from the right. Okay, it goes to 0 but stays positive, right? So together the ratio is positive. So you get what? Positive infinity. Yep. Is that making sense? Everybody's okay? All right, next problem. Say it again. 35x times cosecant x. 35. Remember I gave you the graph of secant, right? You obtain the graph of cosecant the same way. If you know the graph of cosecant, it's going to be helpful. So we have the limit as x goes to what? 2 pi. X going to 2 pi from the left. Is it left? Yes. X times cosecant x. Well, If you don't remember the graph of cosecant, then you should convert to sine first. Limit as x going to 2 pi from the left. So cosecant is 1 over sine, right? So you get this. So x goes to 2 pi from the left, okay? Let me remind you the behavior of sine. So let's say this is the unit circle, okay? Let's say this is the unit circle. If this is the unit circle, right? The sine value, if I take a point here, right? What is the, if this angle here is the angle x, then the sine value is given by which one? Is this height, red height, right? The red height represents the value of sine, right? If this is the unit circle, this is the unit circle. So now, as x goes to 2 pi from the left side, what's the limit of this guy? 2 pi, right? X goes to 2 pi. Okay, what's the limit of the denominator though? Really? Sine of 2 pi is what? Sine of 2 pi is 0, right? Sine of 2 pi is 0. So I know this is going to 0. However, now you have to ask yourself the following question. Here is, let's say, 2 pi, and x is going to 2 pi from what side? Left side. So that means x is less than 2 pi, right? So then, in that case, is sine positive or negative? Think about the graph of sine, right? When you get closer and closer to 2 pi, it's going to 2 pi from negative, right? So then this is going to 0 from the negative. So then this is, oops, blue. Okay, so this is equal to negative infinity. Is that making sense? You're going to 2 pi from the left side of 2 pi, right? So if you're going to 2 pi, if x is going to 2 pi from the left side of 2 pi, so when x is close to 2 pi on the left side of 2 pi, basically x is right here, right? X is like this angle here. So as x gets closer and closer to 2 pi, the value of sine is negative. Or think about the sine graph. 0, pi over 2, pi, 3 pi over 2, and pi, right? Well, let me draw the graph of sine. The graph of sine looks like this, right? So here is 2 pi. Here is 0. And this is the x-axis is right here, right? And this is the y-axis. And notice that when x is close to 2 pi on the left side of 2 pi, sine x is negative. Okay? So that's why you get this. Is everybody okay with that?
Question number 37. Once was -8, that was 0. And once was 0 infinity. How do you come up with that?
Number what?
37.
Let me write down 37. You're looking at the limit at 2, right? The limit as x going to 2 from the right, x squared minus 2x minus 8 divided by x squared minus 5x plus 6. Before I even try to determine the limit, I am going to factor out and see if I can cancel out stuff, okay? So this is equal to the limit x going to 2 from the right. Factor out the numerator, what do you get? X minus 4x plus 2. And here, what do I get? X minus 3 and x minus 2, right? Everybody's okay with that? Okay, nothing cancels out, that's fine. X minus 3 and x minus 2. Now we're going to figure out what's the limit. What's the limit of the numerator? Notice that what's the limit of the first term when x goes to 2? It goes to minus 2. That's the limit. Let me use an arrow. So it goes to negative 2. What's the limit of this guy? It's going to be 4. Okay? In the denominator, this guy goes to where? It goes to negative 1, right? 2 minus 3, right? And what's the limit of this guy? 0. Now together the denominator goes to 0, right? The numerator goes to negative 8. The denominator goes to 0. So I know the limit would be one of the infinity or negative infinity. Now I have to determine the sign though, right? Now when x is close to 2, on the right side of 2, x minus 2 is positive or negative? Here is 2. X is going to 2 from the right. When x is close to 2 on the right side of 2, x minus 2 is what? This guy is positive. This guy is negative. This guy is negative. This guy is positive, right? So what do I have? Positive. 2 negative, 2 positive, right? So it's positive. 2 negative, 2 positive, right? Even numbers, right? Negative divided by negative is positive. You guys are okay with that? Or you can say negative times positive, negative in the denominator, negative in the numerator, negative over negative is positive. Okay. Anything else from this 1.5? Number 7. Okay, number 7 is a graph. You have the graph in front of you? Okay, I'm not going to draw this. First of all, let's look at D, right? I'm going to start with D. What's the limit at 2 from the left of g of t, right? So you have the graph and locate the number 2. And if you go to 2 from the left side, right, then the limit is going to what? It is going to 2, isn't it? How about E? You are going to 2 from the right. So then the graph is going to 0, right? The height of the graph is going to 0 when x goes to 2 from the right. Is this making sense to you? And what's the F? What is F? The limit doesn't exist, right? Because the left-hand limit at 2 is 2. The right-hand limit is 0. They are not the same. So the limit doesn't exist at 2. The two-sided limit does not exist at 2. Is that okay? All right, so that's how you could do that. Okay. Anything else from 1.5? Yeah, I'm gonna get there. It doesn't matter which one we do first. Okay, so let me go to 3.4 because he already asked it. Then we're gonna go to 1.6. Okay, 3.4. Okay, section 3.4. Which one did you want? 29, and you had something too?
19.
Okay. Okay, I'm going to do 29 first, and then I'm going to go back to 19. 29 is the limit as x goes to infinity of x times sine of 1 over x. The limit as x goes to infinity of x times sine of 1 over x. Okay, now in this case what I'm going to do is, first of all, I am going to turn this limit. What I'm going to do is I'm going to replace x by 1 over theta. Okay, it would be easy to understand what the limit is if I do that. So if I replace x by 1 over theta, what do I get? 1 over theta here, sine of what? 1 over theta is the same as what? Right? And now let's think about what's the limit. So if x goes to infinity, theta goes where? Sorry, if x goes to infinity, let me write it. So what is theta here? So if x is 1 over theta, then theta is what? 1 over x, right? So if x goes to infinity, theta goes where? 0. Right? Theta goes to 0. In fact, theta goes to 0 from the right because x goes to positive infinity. And then what is this limit? The limit as theta goes to 0. It doesn't matter whether left or right. In fact, in this case, I get sine theta divided by theta. And I told you what is this limit in the class. 1. Remember, I told you this limit is 1 without even giving you any explanation why this is 1. I told you, all I said is that the graph looks like this, and there is a hole right there. Okay. Oh, I guess I also showed you the graph of this today when I looked at sine x divided by x graph, right, for horizontal asymptotes. So, so you just have to remember that the limit as theta goes to 0 of sine theta over theta is always 1. Is that making sense? Yeah, you can show it to me if you come up here and show it to me.
This is what I did, and then I cancelled these out, so it will be 1.
Wait a minute, what did you do? Sine of 1 over x is less than what?
Less than, so, like I put it as arrows, and I put 1 over x times x, and here 1 over x sine x.
Where are you getting those though?
I don't know, like I was trying to do.
You're trying to use the sandwich?
Yeah.
Yeah, sandwich would not be.
Which will be 1.
If you want to apply sandwich, let me see. Yes, if you try to apply sandwich, it's not going to work here.
Okay.
So your inequality that you're coming up here, it's not going to work. Okay.
And I can't do it also in this way, right?
What are you saying there? No, you see, you cannot put that x here, right? 1 over x is the angle. That cannot be combined with the x outside of sine.
Okay.
Okay? So this the way you're combining x and 1 over x is not valid. Okay. Is that making sense?
Mm-hmm.
Yeah.
Thank you.
Okay, you need to be careful. Sometimes people have, let's say I have 2 times sine of pi over 2, and sometimes people say this is equal to sine of pi. Is it true? No, right? What's the value of the left hand side? 2 times 1, right? What's the value on the right hand side? 0. You cannot combine this with this, or on this guy. This is the angle, this is what you're multiplying the outside by the sine value by that. Okay. So that you cannot combine the two. All right, let's look at 19. It's a root function. X goes to where? Infinity. Okay, did you try to do rationalizing?
Yes, but I got to rationalize, but I couldn't figure out how to
get from there?
Yeah.
Okay, let's see. 9x squared plus x. 9x squared plus x minus 3x. So we have to find the limit of this quantity. So this is what we are going to do. Limit as x going to infinity. Whenever you see root functions, if nothing else works, then what do? Rationalize. Uh, 9x squared plus x plus 3x divided by 9x squared plus x plus 3x. Okay, so this is equal to what? The limit as x going to infinity. If I multiply the numerator, so what do I get? So this is like divided by 1, right? So in the denominator I have 9x squared plus x root of that plus 3x. In the numerator you're going to get the square of the root and minus the square of 3x, right? So square of the root is 9x squared plus x, and the square of the 3x is 9x squared. So if you multiply out using FOIL, that's what you're going to get. 9x squared cancels out. So you have the limit as x going to infinity of x over 9x squared plus x. I assume you got to this point.
Yes.
Okay, now what's the limit? What's going on? Now the numerator goes to infinity, denominator goes to infinity, right? Well, we don't know what's the limit is by looking at that. So what's the trick when you have infinity over infinity? Factor out the highest order terms, right? So here in the denominator, in the numerator there is nothing to factor out, but in the denominator notice that if I factor out x, I'm going to factor out the highest power of x inside the root, and I'm going to get 9 plus oh, you know what, I'm going to factor out 9x squared. I am going to factor out 9x squared. Then I'm going to get 1 plus 1 over 9x, right? This is inside the square root. And I still have 3x, and I have x. Everybody is okay with that? So now this is the limit as x going to infinity. In the denominator now, what do I have? Root of 9x squared can be separated from the root of 1 plus 1 over 9x. but I still have that plus 3x. Yeah, this is a little bit, it's a little bit of algebra work here. And this is equal to the limit as x going to infinity. You have x over, this is 3x, right? Times the root 1 plus 1 over 9x plus 3x. Now notice that you can factor out the 3x, okay? So this is the limit as x going to infinity. I get 3x factored out, 1 plus 1 over 9x inside the root plus 1, and I have x here. Is that okay? Say it, go, which line? Right now I have this, right? So I am factoring out 3x. So if I factor out 3x, I am remain with this and remain with 1. Now the x's cancel out. So in the numerator now I have 1. And notice that this quantity here goes to 0 when x goes to infinity, right? And then I have root of 1 plus 1, right? So that's 2. And then inside the brackets I get 2 then, right? And then I have a 3 there. So altogether I get what? 1 over 6. 3 times 2. Are we okay with that? Questions, or should I go up or down? Let me know. Yeah. Go up.
Yeah, the square root.
Mm-hmm.
Why didn't you say factor out the 9x squared?
I factored out 9x squared.
No, just took it from root. Square from root.
If you can do this calculation in your head, if you want to directly write that, so from this step, right? If you want to go all the way up to this step, if you could do that in your head, go ahead and do that. Okay. But the reason I showed you, because sometimes when people try to do all these things at the same time, they make a mistake. Okay. Yeah. Which x? The 6. Okay, first of all, I canceled out the x's, right? So once I cancel out the x's, what I get is 1 divided by 3 times root of 1 plus 1 over 9x plus a 1, right? So once I got rid of that x, right? Now when x goes to infinity, 1 over 9x becomes 0, right? So then I have what? I have root of 1 plus 1 in the brackets, and then I have a 3 outside, right? But what is root of 1 plus 1? 2. So that's how I'm getting 6. Right? Okay. Large eraser. Okay, 3.4. Anything else from 3.4? Yes. T goes to infinity. T goes to infinity. Root t plus t squared, root t plus t squared over 2t minus t squared, 2t minus t squared. Again, in this case, all you need to do is factor out the highest order term, or the biggest power of t. So in this case, I am just going to do the following. I am going to factor out t squared here, and then I'm going to get root t over t squared here plus 1. And if I factor out t squared here, I get 2t over t squared minus a 1, right? Okay, so then what is that? T squared cancels out. What is root t over t squared? Root of t is t to the half, right? So you're dividing that by t squared. Wouldn't that be 1 over t to the 2 minus a half? Is that right? T to the half divided by t squared, that's the same as 1 over t to the 2 minus a half. You subtract the exponents when you divide. So then what I'm getting is 1 over t to the 3 half here plus 1 divided by, this is easier, 2 over t minus 1. Now notice that this guy is going where?
Here.
This guy?
Yeah.
So what are you left with? Plus 1 over negative 1, which is negative 1. Any other questions from 3-4? $17. Question number 17. Okay. Go ahead. What is that? 17 is you have root of 9x to the 6. 9x to the 6 minus x. Root of that divided by x cubed plus 1. X cubed plus 1. Limit as x going to infinity again, I assume. Yeah. Again, in this case, just factor out the biggest power of x, okay? So x goes to infinity. I am going to factor out x to the 6. You can also factor out 9x to the 6 if you want. Okay? And then you get 1 minus x divided by 9x to the 6, right? And you still have the root. You have x cubed times 1 plus 1 over x cubed. This is equal to what? This would be the root of 9x to the 6, the root of 1 minus 1 over 9x to the 5, right? Divided by x cubed, 1 plus 1 over x cubed. This is the limit as x going to infinity. What is root of 9? 3. What is root of x to the 6? And then 1 minus 1 over 9 x to the 5 x cubed, 1 plus 1 over x cubed. X cubed cancels out. This guy goes to 0, this guy goes to 0, right? So what's the limit? The limit would be, in the numerator I get 3 times root of 1, and in the denominator I get 1, so it's just 3. Is that okay? Anything else from 3-4? If you want to leave, that's fine, okay? If you want to ask more questions, I can stay. Section 3.4, any other questions? Section 3.4, yeah. 25, okay. Okay, I will be going out of I will step out of my office after this, and I will be back at 2:30. Okay, so if you want me to help you later, you can come at 2:30. Okay, I'm going to answer number 25 for you. 25 is the limit as x going to negative infinity. Limit as x going to negative infinity. X to the 4 plus x to the 5. X to the 4 plus x to the 5. Notice what's going on here. What's the limit of the first term? Negative infinity. The limit of the second term is sorry, what am I saying? Yeah, positive infinity for the first one, negative infinity the second one. So I don't know what the limit is. If both of them are positive infinity, then I know that the limit is what? Positive infinity. If both of them are negative infinity, the limit would be negative infinity. But infinity minus infinity doesn't tell me what the limit is.
How do you know that the second one is negative infinity?
Because x is going to negative infinity. So x is negative, so actually 5 would be negative. But actually 4 would be positive because it's even power. Okay, in this case, again, you're going to factor out what? Factor out x to the 5. What do you get? You get this, right? Am I right? Okay, what's going on with this guy?
0.
So it's going to 1, right? This guy is going to 1. What is happening to this guy? It is still going to where? So one factor is becoming big and negative, the other factor is becoming 1. So the product will become what? Negative and big, right? If one factor is negative big, the other one is close to 1, the product would be negative and big, right? So this would be negative infinity. This guy goes to negative infinity means is becoming big and negative. This guy is becoming 1. So that when you multiply, you're going to get big and negative, right? Making sense? So let's say if you multiply negative 5 million with negative 5 million with 0.9, right? This is close to 1, so 0.9. And negative 5 million. Multiply them, you get negative big number, right? Everybody's okay? All right.